Hello everyone, welcome to the video lecture series of cryptography network security. I am your instructor Dr. Ramesh Prajapati, and today I am going to discuss the substitution technique 1. So let's see the agenda of this video lecture. The first, polyalphabetic cipher. Second, there are two types of polyalphabetic cipher. First is a beginner cipher and the second is a Varnam cipher. And the Varnam cipher is also called the one-time period. So let's see the what do you mean by polyalphabetic cipher, right? So before going to see the polyalphabetic cipher, the one drawback of the Hill cipher is the attacker can capture the message if he or she know the plain text. So would we overcome this limitation? We are going to see the second substitution technique is a polyalphabetic cipher. So now let's see the polyalphabetic cipher is a substitution cipher. It is a substitution cipher, and here the cipher alphabet for plain alphabet may be different at different places during the encryption process. It means here, if we are considering our plain text message, and each and every plain text message, the different types of ciphertext alphabets are there. Now, what is the difference between the monoalphabetic cipher and the polyalphabetic cipher? In a monoalphabetic cipher, we apply the encryption using only the one fixed alphabet. It means that there is a one fixed alphabets available for a monoalphabetic cipher. It means it are considering the plain text message ABCD up to so and Z. Now the ciphertext message, it means that the first letter of the plain text is A, it's the ciphertext letter is of Y. If we are considering the second letter of the plain text is B, its ciphertext value is G. It means that here there is a fixed alphabet. The ciphertext is a fixed for particular plain text message. Now in the polyalphabetic cipher, the plain text alphabet may be different at the different place during the encryption process. Now the relationship, now that's why it follow the one to many relationship, because the one plain text character there will be a multiple of a ciphertext character. So that's why this relation is called the one to many. Now let's see, here you are given a one matrix. Here the every 25 characters of the key will be repeated. Here in this table of matrix, in this matrix, the number of column is represent the plain text, number of rows represent the key. So here each row of the table is shifted to one character. In this each row of this table is shifting to the character of right. Each row of the table is shifting one character to the right. It means the first row is shift to 0, second row is shift to 1, and the 24th row is last row is shift to the 25th. It means here the first row A B C D E F G, second row is shift to the position 1. It means that B C D E F G, the third row is start from the C D E F G up to 25th. Now here the plain text is represented in a row and the key is represented in a column. Key is represented in a column. Now write the key repeatedly so the size of the key become a size of the message. So now here you have given a plain text hello and the key is GMGMG. Now to make a cipher text. Now here you have given a plain text hello and the key GMGMG. Now so to take a plain text of the first character and the key pair and the key and the first letter of the key. Now to see the intersection of the row and the intersection of the plain text and the key. So now here you can see if the first plain text letter is H, the first letter is H. So now here we are considering the H. Now the first letter of the key is G. So now to see the cross point of the plain text character and the key character, now you will get the N. So now the first letter of the cipher text will be N. Now we will consider the second letter of the plain text E and the key is M. So now see the intersection point of this letter E and the M, you will get the Q. So now this is the second character of the cipher text. Now we will repeat these things until the final character will be converted into the cipher text block. So this is the method of a polyalphabetic cipher. Now next there are two techniques of a polyalphabetic cipher. The first is a Wisner cipher. So let's see, the first is a Wisner cipher. The Wisner cipher is a one method for encrypting a alphabetic text. It means that it is one method to encrypt the alphabet. After applying the encryption, it generating a cipher text and the cipher text will be sent to the receiver. Now there is one formula, one mathematical notation to convert your plain text into the cipher text and the cipher text into the plain text. So let's see. Now you can see the P equal to P represent P is a plain text and it converted and it divided to a number of blocks like P1, P2, P3. Now it means that each and every character have assigned a P1. It means that if you are considering H, it represents as a first character of the plain text message is P1, second character of the plain text message represents P2, third character of the plain text message represents P3. Now same, the C equal to C1, C2 up to C3. Now the key equal to K1, K2 up to Km. Now there is one formula to encrypt the message. So the encryption equal to CI equal to PI plus KI and the decryption equal to PI equal to CI minus KI. Now here the one condition, the key must be as long as the plain text, else repeat the keyword. It means your keys should be, your key must be long as a plain text message. If the key is very small, so you have to repeat the keyword or repeat the key. Now here you can see the C equal to P1 K1 plus P2 K2 plus up to PM plus KM mode 26. Through this calculation you will get the cipher text. Now we will do the reverse procedure decryption. So P equal to C1 minus K1, C2 minus K2 up to CM minus K mode 26. So with the help of this formula you can encrypt the data and decrypt the data, or we can say that encrypt the message and decrypt the message. So let's see the one example to clear this idea. Okay, here we can consider the encrypt your message is a C is a listening. This is your message and your keyword is a Pascal, or we can say the key is size is a Pascal and it's 6 character keyword. Now initially we are representing we will represent the alphabet value into the numeric. Now we will represent the numeric representation of this keyword. So if we are considering the P, it's a numerical representation of 15. A, its numerical representation is 0. S, its numerical representation is 18. Now same, the key string is a repetition of this initial key string. Now I already told you the key is repeated. Now so the so that the size of the key become a size of the message. So now let's see. Now this is your plain text message. So plain text message divided into the pair of 6 because the size of the key is 6. That's why we need to split the plain text message into the pair of 6. Split the plain text message in a pair of 6. So the SHEISL, this is the first pair of plain text. Second pair is ISTENI, and last is NG. Now each and every alphabet have some numeric representation. So here if we are considering the S, its numerical representation is 18. If you are considering the H, its numerical representation is 7. Now same for key also, right? The Pascal, the P, the value, the numerical representation of P is 15. So now you will get both the things, the value of plain text and the value of key string. So now we are adding this to, you will get the cipher text, first character of the cipher text. So the 18 plus 15, the first character of the plain text and the key string is S, is 18 and the 15. Or you can say that the value of first plain text is 18 and the second key string is 15. So now we will add this two number, 18 plus 15, you will get the 33. That means that whatever value you will get after the P1 plus C1, you will subtract from the 26. So now you will get a 33. So 33 minus 26, you will get the 7. So now we'll convert this value into the alphabet. So the value of 7, its alphabet is H. Same for second pair of plain text, second character is a plain text H, its numerical representation is 7, and the key is A, its numerical representation is 0. So the 7 plus 0, you will get the 7. So now we converted this 7 into the H. So now here you can see your plain text message is different, right? But each and every plain text message, each and every plain text character, the different cipher text are there. Now this is the procedure of Vigenère cipher. Now we will do the same process until the final plain text character will be converted into the cipher text character. Now you will get the cipher text is HH, WKS, WKS, WXH, LG and TG. This is your cipher text. Now here the multiple cipher text letter for each plain text letter I already discussed, right? For each and every plain text letter there will be a multiple cipher text letters are there. That's why it is called the one-to-many relation. Now there is one limitation over here, the repetition of key. Now each and every time the key will be repeated. So now if the attacker, sometimes attacker capture the key, so sometimes attacker knows the key or it try to capture the key. Now it find out all the message which was communicated by sender A and sender B and the future message also. So this is the limitation. To overcome this limitation, we will use the second technique, Varnam cipher. Now the Varnam cipher will be operated on a beat by beat operation. It means that the operation to the individual beat of the plain text and the key string will be used. Individual operation of the bit. It means that this quantum cipher will work on a bit by bit operation, or we can say that is called the string cipher. So here the key string generate the key, and the plaintext is represented as a pi, and the key is represented as the ki. Now your plaintext is divided to the number of bit, and the operation to the individual bit of a plaintext is the key string. Now we are applying the XOR operation on a individual bit of plaintext and the key string. So now we are applying the XOR operation on a plaintext character, first plaintext character and the first bit of key. After applying the XOR, it is generating a ciphertext. Now, if I want to convert this ciphertext into a plain text, so we will do the reverse process. Now you have a ciphertext. Now we are applying the XOR operation on the first character of the ciphertext or first bit of ciphertext and the first bit of key. After applying the XOR, it is generating a original message. So this is called the quantum cipher. This is the first technique of the quantum cipher. Now let's see the second technique of the quantum cipher is also called the one-time paid, or it is called the OTP. Now here the plaintext is combined with the random key. Here the number of keys are there, and each and every time the value of key will be different. Now here the key is at least long, the message or the data must be encrypted. It means that the length of the key is equal to the length of the message. It means that the length of the key should be equal to the message of the plaintext message. Now here, once the key is used, the sender and the receiver must destroy that key after use. It means that each key is used only once. Right? Sender and receiver must destroy that key after use. It means that the key is used only once. Now let's see the one example over here. Here you have given a number of alphabet. You know that, right? The assign a number to each character of the plaintext, like A equal to 0, B equal to 1, up to 7. Last is Z, its value is 25. Now assign a number to each character of the plaintext and the key according to the alphabet order. Now here you have given upon plaintext message I am Indian. The second is a key AN anti-Pakistan. Your key is anti-Pakistan, ANTI PAKISTA, and the plaintext is IAM ANINDIAN. Now the each and every plaintext character will be assigned a numeric value. So if we are considering I, its numeric value is 8. If we are considering the numeric value, if we are considering the plaintext letter is A, its numeric value is 0. Now same for key, each and every key we have assigned, we are going to assign the value. So if you are considering the key, the first character of key is A, its value is 0. Second is M, its value is 30. Now add up both the number, plaintext and the character number and the key. Now add up both the number. It means that 8 plus 0 you will get the 8, 0 plus 13 you will get the 13, 12 plus 19 you will get the 31. Now fourth number step, subtract the number from the 26 if the added number is greater than 26. It means the added number is greater than 26, so you have to subtract that number from the 26. So now here you can see the blue color. Blue color is represent the value is greater than the 26. So now you have to subtract that value from the 26. So now the value 19 and now the value is 12 plus 19, you will get 31. So sub 31 minus 26 you will get the 5. Again you have to now you will get the ciphertext value of ciphertext. Now again you will convert this ciphertext value into the alphabet. So now your ciphertext is INFIC IXLATM. Now we will do the reverse process. It means that we will encrypt the data. So same in encryption, in a decryption we are considering the ciphertext. The key is same. Now again each and every alphabet we have to assign the value. So now I attribute the value, numerical representation is 8 and numerical representation is 13. Now same for key. If you are considering the key is A, its numerical representation is 0 and its numerical representation is 13. Now again, now we will do the subtraction. Now we will do the subtraction. So you will get the 8 minus 8, you will get 8. 13 minus 13, you will get the 0. Now the 5 minus 19, you will get the minus 14. So now here again the negative values are there. So now you cannot consider the negative value. So now again you will convert into the positive value. So now you to add a 26. So the 26 minus 14, 26 minus 14, you will get the 12. Now again the 15 minus 13, you will get, now minus 13 is there. So again you have to count. Now again you have to perform the 26 will be added to minus 13. So 26 minus 13, you will get 13. So now finally you will get the ciphertext. The value of ciphertext 8, 0, 12, 0, 13. Now we'll convert this value into the alphabet. So now the value of numeric alphabet of 8 is I, alphabet of 0 is A, alphabet of 12 is M. So now you will get the original message and the plain text message is I am England. So this is a procedure to convert your plain text into ciphertext into the plain text using the one cipher, or we can say there is a one-time paid OTP. Now there is some advantages are there. One with the advantage of a one-time paid, only know the scheme that is unbreakable. It means that here it produces the random number of key. So there is no statistical relationship between the ciphertext and the plain text. Second advantage is that there are number of plain text message. Now it means that if you are considering the one ciphertext message, apply the different key on a ciphertext, it will generate the different ciphertext block. So here given two potential plain text message, attacker can't identify the correct message. It means that each and every time we are using the new key. Each and every time we are generating a new key and it generating a new ciphertext. So attacker can't identify the which is the key is correct and which is the message is correct. So, but there is one limitation of a one-time paid. It means the difficult to provide the large number of random key, because here we should generate the large number of key. So it is very difficult to generate the large number of key. Now second limitation, distributing the unique long random key is difficult. It means that once the random key will be generated, after that this key will be distributed to the different users in the network. So it is very difficult. So these are the two limitations. That's why we in a simple encryption or decryption we cannot use a one-time paid, right? If you have required the security is very high, at that time we will use the one-time paid. Here I already explained you. Okay, here the one ciphertext pair. One ciphertext is there. Based on that ciphertext, I want to obtain the plain text message. So here the one ciphertext message, we are applying the different type of key, like key K1, key K2, key 3 up to key 4. Now each and every time it generating a different random key. Now we are applying the XOR on a ciphertext message and a key After applying text tone, it is running a different side plain text. That's why it is more secure. So attacker doesn't identify which is the correct message, which is the correct plain text message, and which is the correct key. I hope you clear this idea. Thank you.